Mhm. Thank you so much. Right.
Okay, thank you very much. And I know that Dr. Tita Dut will be joined by one of his colleagues today, where they will be taking us through some of the practical sessions today. So maybe you can also introduce the other person if he's already there.
Okay, so Zach is with me. Zach is with me. He's Zach Salifu. And then Zach is I don't know, any of you know Kaggle? Any of you here know Kaggle? No one? All right. So he's a grandmaster on Kaggle. So Kaggle is this. Okay, good. Sylvia Muyingo. Sylvia, good. So Zach is a grandmaster on Kaggle, and he's with me. He leads our AI team. So he'll be joining us. Thank you.
Thank you very much. And I think from this point, I'll take it to you to proceed. I don't know if you can also, you can be able to share your presentation and we can start.
Okay. So I'll do that.
Okay. And also feel free to enable your video or something.
Okay, you need me to enable the video and then share screen?
No, not really.
Okay. So
Okay,
let
great.
me maybe later within I'll just enable. So let me try and then share screen. Sorry. Let's see. Can you all see my screen?
Yes.
Okay, good. So first off, I'm not really a PowerPoint person. I don't know if there was, I mean, back in medical school, I wasn't the kind I would really like as much PowerPoint. I like the vibe. I like the conversation. I like the when our lecturer would say, hey, forget about the PowerPoint and let's talk. And let's hear what you have. Let's break down things. So sorry if it's if you don't have as much, if you're a deep PowerPoint person, sorry to disappoint you first. But trust me, we are going to talk about everything that you would want us to know. Also, I don't want it to be very fixed and rigid in that strictly what I'm saying. Feel free to show your hand, and then we can talk about something that you find interesting, that you think that you've realized, or feel free to just stop me anywhere. Okay, so we'll look at this is just something I've gathered. Healthcare data explosion, the state of healthcare data, a bit about machine learning, deep learning, AI. We are now in the AI craze. I also we'll look at case studies, but I'll sway a bit from that and look at it in terms of local context, and then data privacy, ethical considerations, and then AI in African healthcare. Joel, I gather that these are mostly participants who are interested in building in the tech space, technology to improve access, right?
Yes.
Exactly, excellent. So
Mm.
I'm sure a few of you have begun looking at what's all this AI thing and all. We'll talk everything that. Okay, so um, you know what mental health is. You most likely know you've know some of the problems. So I'm not really going to focus on that. What I want us to look at is the healthcare data. From there, then we can make sense of it. We've seen NLP, natural language processing applications, or software like ChatGPT, and this whole AI craze. And it's built on data, quality data, cleaning data. And then I hear lots of you, a number of you are early researchers or into research. So I shouldn't go much into that. But we've witnessed an explosion in data in healthcare, right? And this is something that I think we should be paying attention to in our part of the world. There's the data deluge. From the mid 20th century, the medical information, the doubling time was just a matter of a few decades. It would take a few decades to do that. But 2010 to early 2020s, we've looked at it in terms of it has shrunk to years and months. So in 2025, we are expecting that the global healthcare data will reach about 10 zettabytes. I don't want to bore you with stats. My point is I mean, there's more data around us than we probably even consider. How do we harness the right data to be able to build the tools that we need, to be able to build the digital frameworks that we need to be able to provide services to our people? You're looking at it in terms of electronic health records. East Africa, I'm guessing, I know Kenya. I don't know the terrain in Kenya. If you have, in Ghana, we have a LIMS. LIMS is the Light Wave Health Information Medical System. So this is used by the public hospital. So this is a government initiative, the Ministry of Health in Ghana, where the public hospitals and the quasi-government ones use this electronic health record to be able to provide care. So doctors, patients, doctors, nurses, the healthcare team, everybody has access to this. That is a very good data source to consider. Right. Wearable devices, patient registries. So how are we able to extract this data to be able to provide this service we need in terms of mental health care? In Ghana, we have psychologists, psychiatrists who see patients and then enter these through the LIMS. And for me, the question has always been, how can we extract this data? What sense can we make of the data? And then the fragmentation concerns are also very worrying. For example, as an individual, say an entrepreneur or someone building in the tech space, there's a multitude. I mean, there's a spring up of startups, healthcare organizations. I mean, some of you also be starting your own thing. Every tech and everybody seems to build in silo, right? Fragmented. How do we build an ecosystem that is able to pull all this data and then make sense of it? Africans need to tell our own story. We should be able to tell our story. And then telling our story goes beyond just the verbal communicate. I mean, it goes beyond just, for example, saying, let me give you the story of Zomujo so that it brings it into context. And then Zomujo for us means personalized healthcare. And I've started Zomujo because I lost a friend to suicide. This was a friend, we had gone to high school together, very, very smart guy, all A's. He was one of those people that I even looked up to. We all looked up to him. He got into medical school, was doing very well. The only son of a reverend minister. He would hit the gym let's call him X. He would hit the gym, fun guy to be around with. After 30 of medical school, we lost him to suicide. And as his friend, the lingering question was I there for him? Was I there to be able to help him open up? Did I create a safe space for him? There are several others in medical school, I realized, among doctors, colleague doctors, physician burnout, society in general. And that's really why we started Zomujo. So again, we are talking all this, but it's not, I've sorry if it's not in the PowerPoint. I just wanted to have a good conversation. Joel, is it good this way?
Yeah, it's perfect.
Okay, good. So that's the story of Zomujo and how it came about and losing a friend to suicide. And the first question for me was, how could I have been there for my friend and be able to probably pick up what was eating him up? Was it that it was too grave a thing to share that maybe sharing it would mean that would all despise him or turn him away? Was it something that he thought that he would take to his grave and wouldn't want anybody to know? We didn't know. We all don't know up to now. Is it something that he couldn't even share with his father, mother, siblings? So that's really was the awakening. How there's several people going through mental health difficulties, persons all around us. How are we going to be able to create the safe space for them using technology? And how can we make sense of the data? How are you able to, we can't, good intentions are not enough. I see all of you are here, you want to do very good work in the tech space, healthcare space, but good intentions are not enough. Can we solve what we can't measure? And if we are also solving a problem, are we able to get the right feedback loops to be able to build on that? Back to it. So that's why we started Zomojo. Basically is how we will be able to provide this care for persons like X, my friend, who lost his life to suicide. And how will we be able to scale this intervention? I'll come to that, but this is just context. Again, privacy concerns and interoperability challenges. So I'll tie it into our work at Zomojo so that it's I mean relatable to you as well. Founding Zomojo, we're looking at it as, so we built an app. So there was an app in Play Store and App Store. The whole idea was simple, that persons with mental health difficulties should be able to have access to help or resources. At that time, we weren't thinking in terms of chatbots, but to actively connect to people with lived experience, and I'll come to that. So the whole idea was connecting persons with mental health difficulties to persons who were trained to provide first line support. So it was basically, we went to tertiary institutions. I was in medical school then, went to various tertiary institutions, spoke to, I mean, since I was in school, this was something I was facing head on, as this was a problem I was also going through. I also had my bouts of depression, anxiety. So I could relate to the problem firsthand. So we needed a community of a peer networking community, a peer support group. So got the psychiatry department, psychology department of my university, got them to train a few of us, about 100. How are we able to provide help to our friends when they come to us? Sometimes our friends come to us, are we able to listen to them? All this I'm saying, I'm going to tie it into the technology, but are we able to listen? Do we have the expertise to be able to even listen to them without judging and to point them to right resources? So the whole idea was to be able to be in that capacity to provide that service. We got trained, about 120 of us. And the next thing was, how can we provide it by an anonymous approach? That was when we decided to build a software to handle that. Like I mentioned, the App Store, Play Store. We built the software in that it was confidential with privacy. So confidential in terms of the person who needs help, the person with a mental health issue or challenge or difficulty won't be able to see the peer counselor, and the peer counselor won't see the person. So it comes. So let's say Joel is the Sylvia Muyungo. Let's say Sylvia is the peer counselor, and I'm the one who needs help. I can go onto the platform, and then in less than 10 minutes, I'll be connected to a peer counselor who could be Sylvia. So any of the 120 peer counselors in training or who had been trained. And it would connect us in less than 10 minutes. It would also take us to a private chat room where Sylvia wouldn't see my name. I wouldn't also see Sylvia's name. But the confidence is the fact that Sylvia has been trained by some of the leading psychiatrists and psychologists we have in the country. I mean, using Sylvia as an example, have been accredited to be able to provide first-line support. So that was just the concept behind Zomojo. So in this way, we realized that people were able to open up, people were able to share. And then the next phase, I'll talk about it in scaling up. But again, identifying the problem, being able to solve it. For me, I tell people there's Y Combinator. Y Combinator is an accelerator, one of the world's leading accelerators. I mean, Paul Graham has this, Paul Graham was the founder, is the founder, one of the founders. He has this mantra about doing things that don't scale. In the initial phase of building your tech or leveraging the tech and the data, people are in a haste to build the technology and to cover all the fancy things. But first thing I would really entreat you or to pay attention to is, can I first do this without the tech? Can I do it manually? And where does the tech come in? Does the tech come in as an enabler or a facilitator, or the tech is the core offering? Glorious, were you saying something? Glorious Jusang. All right. Okay. So that is really first. Once we're able to start off without the technology, then we look at how can I bring in the technology to facilitate what I'm doing. All right. So privacy, and on the platform, the Zomujo platform, we also realized that, I mean, people would also be concerned about their privacy. I'm sharing all this thing with the peer counselor or peer support person. What's happening to my data? So we did it such that right at the end of the session, all the data is cleared. I mean, at the front end view, we explained to them that the backend would have to keep it for purpose, but we really encrypted the backend. And at the front end, we cleared it. So the front end is on the, say, the patient or the user, sorry to say, I mean, the clients or the user side of things. So at the end of this chat with your peer counselor or your facilitator on the app, it was cleared. So this also provided a certain layer of trust, security, and yes, and that bond. They knew that once they came on the platform, they would be able to talk to a peer counselor without being judged. The peer counselor doesn't necessarily have to, they don't have to share their personal information by way of name with the peer counselor. They could actually talk to a real human being who could relate to them. These peer counselors were persons with lived experience that we had trained in partnership with some of the leading psychologists and psychiatrists, the Psychiatry Association of Ghana, the Ghana Psychology Association, the Mental Health Authority, and all that. And this was the Zomujo intervention. Let me skip this side. I'll let Zach come to it. We'll talk a bit more AI things, but Zach would come to it. So let me just come to, yes. In our bid to build up mental health solutions, to build tech solutions in the mental health space, I would even try to expand it to healthcare space in general. For me, I think of in terms of safety, affordability, appropriate to the circumstance, and then high quality. Safe, affordable, high quality, appropriate. I usually say SAQ, SAAQ. In African context, you know our people. There's enough data to show the costs of care, how access to these resources can be a problem. Although we know that governments and private investors, public PPPs, public-private partnerships are trying to scale access to internet, there's still a big problem to access. And for us in Ghana, and even for the most part of Africa, we know there's a paucity of mental health professionals. There are scarce mental health professionals. So already the brick and mortar facilities aren't accessible to them by way of care. And so if you're also going to build tech solutions and innovations and leverage all this data, if you are going to build for people who can't access the internet connectivity, then we are not too different from disruption isn't really taking place. Right. For me, I look at disruptive technologies as those that can augment, supplement, and scale the models of care and then bridge gaps in access. If you are not bridging the gap in access, in tech, we like to tickle ourselves and laugh. You hear words like leveraging, this breakthrough, revolutionizing, transforming, blockchain, this, that. But are we really, really solving the problems of the people? Or we want to build certain complex systems that don't really address the root cause of what we are trying to solve? And I also think that persons with lived experience should be central to the design. In my case, I was one as an individual with lived experience. Several of my friends, And it was like a community, a friend coming. People would always refer to Zomujo. We started as just a community for about 120 people. People come to us with their problems. We sit them down, we talk, kept expanding. Friendship network, right? Like talk therapy before the technology came in. And we realized that we could share, whenever people came, we could share our problems with them. We could really give them our real life experience. We could tell them that I have been through this. So that was really central in our design to be able to incorporate that. And for you, for whatever tech you are building, it may not necessarily be manned by individuals or personnel. Maybe they say it's we're also looking at those options, but let's say it's a mood tracker or mental health screening assessments you to diagnose, or any of the AI ones, chatbots, let's say use a chatbot, or you even use, let's say, GPT-4 as an interface or as the UI layer, and then it's powered by the LLMs, could be Anthropic or any of that. All that too, as long as the technology is behind that, we should be actively consider persons with mental health difficulties and also persons with lived experience to be able to add to their skill set. It really helps in the disruption and bridging the access to care. I won't talk much here. All right. AI algorithms, for us, we're looking at fairness, transparency, accountability. I like to think about it in terms of fat. It should really be fat, it should be fair, it should be accountable, it should be transparent. All right. Again, it was, if we're building in the United States, in the UK, go for conferences and they keep talking about minority. Sometimes, we blacks could be minority there. But in our own ecosystem, say Kenyans, Ghanaians, Africans, who are the minority in the mental health care space that we are building for? For us, we realized women, children, were some of the persons who had been displaced by, refugees. All these people are persons that our interventions targeted. And you realize that we built, to an extent, we built these tools for them, and they couldn't access. Some couldn't access it because they didn't even have smartphones. For some, others to internet connectivity, buying mobile data. And so we realized that we also had to bring in another layer. So that's when we introduced our USSD, our toll-free option. So with the toll-free, it's always mounted by a dedicated psychologist, and persons could just phone in and be, assisted by a dedicated psychologist. Initially, we had some IVR. So based on the context of the call, we were able to route to the most appropriate person to handle the care. So there was always like a customer representative and then psychologists or specialists who could handle these cases. Realized that really was the breakthrough for us, in that with a toll-free line, they would call, they will not be billed, and then we handle the charges. So we realized that, the demand was even outstripping the supply from our end. And so if you're also building, I would like you to consider these things. Consider things in terms of, consider the accessibility in terms of the bandwidth. You could also build your apps or your technology to have a relatively low bandwidth. Consider offline connectivity. Consider USSD. In Ghana, I don't know, it's Kenya, Joel, M-Pesa, is MPESA. It's in Kenya, right?
Yes.
Yes. And then do you have mobile money, MTN, mobile money, Momo?
Yes, no. You mean Momo?
Yes, MTN mobile money.
I know you can transact
Okay.
mobile money on ATM.
Okay, that's
Not
fair.
specifically the app.
All right. So in Ghana, we have Momo, MTN, mobile money. And we have all these fintech apps around us, Flutterwave, Paystack, Wise. We have all these fintech apps. And if you look at, I mean, MTN to have their app, but approaching or getting the unbanked and the non-consumption market really, really happened with USSD, where everybody, by dialing a short code, was able to have access to their own account, was able to save money, transfer money, withdraw money. That was it. If I mean it was able to, this simple technology as USSD and not as even blockchain, AI, this, that, was able to, I mean, my grandmother used MTN mobile money, USSD. She dialed *124#. She knows that she can follow a few prompts and send money. She can deposit money to via vendor. And that, I mean, the whole complex cycle of going to the bank, I mean, some banks having you to, as part of KYC, draw direction to your house. It's solved that just using a USSD code. And today, MTN's, I mean, when they come up with their profits, quarterly profit earnings, it's more all the fintech apps. I mean, it's if it was any organization that came up with, it's the most brilliant low bandwidth technology I can mention. It's in the financial space, but I also think that in healthcare space, we should also be considering things like that. For us, and not copy directly from the West, we should build in terms of our local context. If we can get USSD offerings that are very innovative and can address the critical mass and still be sustainable, I think that's going to unlock. I don't know what that's going to be. Maybe one of you is building it, and I really hope to see one of you build that. But I think that's really going to be incredible. Yes, so future trends in AI and healthcare. I don't know if any of you is thinking about this in the space, but genomics is something that appeals to me a lot. And I think the future, personalized medicine, disease prediction, already there's been lots of research to back that. I don't know if this context will be okay for that. But in terms of monitoring, wearables, lots of, now we see Apple Watch, Samsung Watch, fitness apps, all, I mean, fitness wearables, sensors. There's lots of data being generated. As Africans, and are we generating our own data? Are we being able to build or cipher our own data from all this we are doing? And how are we telling our story using our own data? So I also have, Joel, is it possible to share a list of innovations or things that people could be building in that, by my experience, I think people are not building in or they should look into, or that is up to the teams to decide?
I mean, some of them are still developing,
Okay.
so maybe they might not be able to share.
No, okay. I wanted to probably look at it, but it's fine. It's fine. But in the data and the tech space, these are some questions I asked myself, and I really don't have all the answers to. But how are we going to regulate all these without stifling innovation? Right? I mean, we look at the data, technology. Um, we've seen what the European Union is trying to do with regards to regulating AI and then technology. I mean, AI in general. How is it? I mean, is it going to stifle innovation? We know that American, Chinese are the world's largest, I mean, advancement in AI. And as Africans, are we developing roadmaps to leveraging the data and the technology to build for our own people? We are going to, a lot of us, I mean, we'll be building on top of LLMs. Are we, and all these are supposed to train the systems. I was in a meeting with another foreign company. I can't mention the name, and they're trying to do lots in the African sense. But I realized that, I mean, they're pumping lots of money to set up systems, get more healthcare organizations involved, get governments involved in that. But at its core, it was really the data they were after. I realized that they didn't know so much in our context, and they really wanted to build on the data, gather as much data, and then be able to then develop that tailored offense for us. So I think that it could work out in terms of a public-private partnerships where there's probably a mental health authority at Kenya in East Africa. What data do they have? And how can we build on the data to be able to improve the access and the care to them? Remote consultations, telemedicine, mobile apps, these are things that are readily available. I mean, enhancing diagnosis. We've seen it now in the TB, people able to cough and people, I mean, digital sensors. By mental health too, we are getting lots of that, where people are building with regards to wearables, I mean, wearable sensors, able to track a person's psychology or mood. They have CBT guided ones, and then DBT, CBT, all those incorporated meditation, mindfulness, yoga, all these things are, I mean, can be incorporated in the design. So I wouldn't really talk about much about the different tech apps or the tech systems that can be built. Zach may talk about that briefly. And then the data generation and analysis. Okay, I'll let Zach talk about that. But the challenge is really about the availability of the data and then the quality of the data that we'll be looking at. There are some frameworks I like to think about when I'm building. Number one is the data and the privacy. Number two is the clinical evidence, the safety, the usability and accessibility, the security, cultural safety, and then the data sovereignty. These are my frameworks when we are building at our end, Zomojo. And then there are things that you can imagine. I mean, later I can send a more detailed document to Joel. Anybody that's interested, I can send a very detailed one, about 30 pages. And then it also contains some innovative things I think people should be building in the African space that all of you can look at. All right. But out of the top of my head, we need services that can connect users or patients to therapists. But again, how many therapists do we have? Do we have enough? Do we have to train new ones? Do we have to have community health workers? Let's see, Last Mile Health has this model of training community health. I mean, supervise the 4S. I think they have the 4S: salaried, supervised, skilled. There's another S. So they take community workers and they train them and provide them with these 3Ss to be able to provide care. Can we do that in the mental health space? Can we take lay people and turn them into psychotherapists? Can we have government approve of it? Can we then scale that? And can we give them the tools to be able to track their performance? These are all doable, and that is really what we are trying to do at Zomojo. Okay. Sorry. I'll let Zach come in, but I think I usually don't talk more than 30 minutes. If anybody has a question, let's do it. And I'll let Zach come in with the practical side of things. Anybody who is building, if you have a CTO, you are confused as to anywhere you need, I mean, you just want to think about the technology stack, everything. Zach is here to help out on that. But does anybody have a question so far? Oh, Asrat, Desi, Frank, Frederick, Tumaini, Eunice, Lemesa, Naomi Ratemo, Kojo Yao. Kojo, wow. Anybody here has any question? Okay. Joel, would you mind asking me if anybody here is building, has started building already?
Sorry?
Has anybody here started building something in their space, or have they built anything now, even if it's at the concept stage?
Yeah, some of them are starting, but I'm sure they will not want to discuss it here.
Okay, okay.
For the fact that
That makes sense. That makes sense.
the ideas. Yeah.
That makes sense. But
Sure.
I'm more for a practical side of things, in that I would always want them to come up with the questions and then it will guide the flow of things. Otherwise, there's so much to talk about that
Yes.
exactly. We could talk about different aspects. I mean, it's very broad. I see it's very broad. So then I really want to know, maybe somebody has a question, then we can then walk through together. Because
Okay.
otherwise,
So kindly put your questions in the chat and maybe we can
yeah.
try to see what kind of content or what kind of information you're looking from our facilitator. And thank you at least for giving us the heads up. Maybe we can now, from what you have presented, try to think around that and see like the tech innovations that are possible within the mental health space. So feel free to even raise your hand. And we can unmute you and you can speak.
All right. Yeah. Well, so while they raise their hands, they should think about remote patient monitoring. How, I mean, for me, I'm looking at it in terms of, if you are building as part of sustainability, think about how you would get the government on board. How you generate enough data from your end to be able to show that this is what I'm doing and this is why I think you should come on board. For example, at the hospital, psychologists or psychiatrists will see a patient, or even it could be diabetes or hypertension. And the next time the patient will come to the hospital, it's in, let's say, 6 weeks. Depending, it's in 6 weeks. Between the 6 weeks, what happens? Is the patient non-compliant? Is the patient compliant on medications? Do they have questions? Are they being checked on? How are we monitoring them? Bring it to the mental health space. Few resource personnel, and then maybe patients in for the first time. What is the follow-up like? What is the monitoring? How do we define remission? How do we define recovery? What is the time? How long do they take to recover based on this intervention? All these things patient monitoring is something that I think not many people are building within the space, and we should begin to look at it in terms of mental health. And then education and training, providing education and training. Recently, there was an open call by Being Foundation Botswana Grand Challenges Canada on mental health. There was a request, an RFP for Ghana. Was targeted, was about bullying. Other countries was stigmatization. The question is, how are we able to, for example, in Ghana, they took bullying as a focus area, and they're seeking innovations in bullying. And with some few organizations that I advised, it was, how are we able to, the mental health, in mental health, it goes beyond the individual with the difficulty. Sometimes it's to the family, it's the close people around them. So when you take bullying, for example, bullying occurs in schools, right? We were talking of, bullying in schools, that was the context. So high schools, university, they say cyberbullying, junior high schools. How are we educating them, sensitizing them on bullying? What are the reporting channels going to be like? Can we use technology to help in the reporting channels? Also, are we training teachers to identify them and the side effects of bullying, or the effects of bullying? Can cause, research has shown that can cause depression, anxiety. Are teachers in these schools able to pick up students with these problems? Are they able to identify triggers, signs, and symptoms and refer? Do the teachers need training? How about the parents? So a simple mental health thing, let's say something about bullying, realize that if you take bullying example in schools, it ties in on this. And so that's why I would want to have a questions, then we begin to look at maybe some practical side of things. If you are into AI, my full stack developer is also available, everything. We can give you the practical side of things. Zach, are you here?
Yeah, I'm here.
Right. So Zach is from my end, and Zach is from my end again. He's a grandmaster Kaggle, so he's very good AI technology. So he's around. If you have any questions to practical side of things building, he's available to answer the questions. Oh, is it me or I see some questions here? Okay. Interested in the document, I'll be interested in the document presentation. All right, that's good. RFP. The RFP, I think it was to 12 countries. Ghana was one, India, Peru, Ecuador, that African country, I think Senegal was one, Egypt was one. Yes. Timothy has a question. And Zach, I think you'd come in with a question with that. He says, I'm thinking about a project on, I'm thinking it's ADHD. Timothy, is it ADHD? Okay. Attention deficit disorder. I'm thinking that it's the ADHD of CEOs, and it's important on productivity. Of course, there's enough data to show that there's a huge loss of of productivity costing up to, the last time I read, I'm not too sure, it's up to 50 billion is lost in productivity on account of mental health issues every year. Is it appropriate to build an LLM chatbot that shows motivational message to CEOs every day to carry to them to carry out their day? I was thinking it will reduce the depression to some extent. What do you think? Okay, I'll come in on what I think, and then Zach will also come in on if you are building an LLM for that, maybe some considerations, technical considerations. So ADHD and then of CEOs. So first off, I'm assuming that you would probably have, again, first principles. What is the problem? Have you, are you looking to, are you a for-profit, not for-profit? First, the problem is there, you've identified. Is the problem a big enough thing to be solved? Or how do you want to approach the problem? You want to build LLM chatbots that shows motivational messages. First off, LLM chatbots aren't free. You're going to pay. And then how many CEOs is this problem affecting? Have you done any survey or baseline investigation to show that this is something that they are really concerned about? Because I know that productivity, lots of people get in, but why CEOs? Why not to employees in general, like an EAP employee plan? Why to CEOs exclusively? So is there a big enough market for that? Because there's something that you are even going to pay to build. And then motivational messages. Fair, but is there enough research to show that motivational messages every day would help them in terms of reduce their depression and anxiety? Or you want to do it and then you can do it if there's no research to that. You can do it, gather the data, and then publish on that. It would be interesting to see it. You are thinking it will reduce their depression to an extent? It could. It could. Again, there's no clear data. I've not seen a clear data to support it. I'll look at it. So you might also build to, assets that. What do I think? Yeah, that's really what I think. But know that it's not going to be free. So somebody has got to pay. Good. LLM chatbot. Zach, would you come in? Build the LLM chatbot. He wants to build an LLM chatbot to show messages.
Okay, yeah, to build an LLM chatbot, in fact, these LLMs are very powerful enough that they understand everything. They can generate very good messages for CEOs to reduce their anxiety and depression. But the problem is that these LLMs are trained on large data sets, general information, and if you need to, let's say, build something that is tailored for generating messages or inspirational messages to CEOs, then you need to look in terms of fine tuning. So, what do I mean by fine tuning? Fine tuning means that you are trying to update the model's weight so that it becomes more powerful in your specific use case. Tita mentioned that it's not going to be free. Using an LLM is not going to be free. In fact, it's not going to be free. GPT-4o is very expensive, but you can look in terms of using smaller LLM models, like let's say Llama models, and Mistral, some of the Mistral models, or some other model like the 5A model, a smaller model, even less than 3 billion parameters that you can use. So you can fine tune those models. And what do I mean by fine tune? Just get some data and move it to update the models with. But you may ask me, how do I get the data to do the fine tuning? That is really the problem. Getting data to fine tune a model is very difficult. But right now we have more powerful models like the G models from GPT, from OpenAI and Gemini and all that. You can use these models to generate synthetic data, then you use those data to do the fine tuning. I don't know if that answers your question before I go to my presentation.
Right. So let's just see. Can your idea include an algorithm that breaks down their drivers on productivity? Okay, somebody was okay, your chatbot would more useful to the address drivers. So that's a good point. In your experience with which African country offers the best flexibility to pilot studies on remote mental health service delivery? That's a good one. That's a good one. I would then look at it in terms of the country. It's again, it's about the execution, it's that approach. It's looking in terms of the partnerships and not trying to do everything on your own. From if you look at it in terms of government, which government agency it's involved, can you get them on board? Can you get, if there are resource personnel, in our case, we have the Psychiatry Association of Ghana, that's all the psychiatrists. There's a Ghana Psychological Association, so the psychologists we have in the country, then the Counseling Society, all these ones coming on board, it makes it easier. And also builds, it adds to the credibility layer of things. So I won't look at it in terms of the country, but I would say trying to also get different stakeholders on board. Ghana, in my experience, Ghana has been good. And if you want to come to Ghana, I mean, you're welcome. It's an open space for all, but Kenya too should be good. I mean, there are lots of tech innovations happening in Kenya. I think it's President Ruto, was it William Ruto? I mean, he's been in the news on trying to power, in terms of tech hub, being Kenya as an African tech hub. It's, I mean, central. So I think Kenya too should be good. Okay, Timothy, you said you are satisfied with the response. The pleasure is mine. I'll let Zach talk briefly on the AI ML part, and then if you have practical questions, just bring them up. You are even building, you started something, you are not sure of the back end, you are not sure of the front end, you want to throw in some AI thing, how will you approach it? Just bring, let's look at the practical side of things.
Okay, yeah, thank you very much. I'll continue from, let's see. Okay, so please, can you hear me?
Yes.
Okay, thank you very much. Yeah, my name is Zachary Salifu, and I am the AI engineer at Zomujo. So yeah, I'll touch on the AI, ML, and deep learning part of this presentation. In fact, as Tita mentioned earlier, this presentation was supposed to be on mental health, but I realized that I also have to touch in and add general health, AI, machine learning, and deep learning implementation in general health, just to make it generic for anyone who wants to build around this technology. So I'll start with the difference between machine learning, deep learning, and AI. Yeah, I hope most of us, we've heard about machine learning. Difficult to know the difference between the two, or if you already know them, I'm just reinforcing that. Okay, so to start, I'll start with machine learning. So someone may ask, what is machine learning? In fact, whenever someone asks me this question, I mostly use how kids learn as an analogy as to how machine also learns. We know that when we are teaching kids particular things, so let's say we have some fruits, then we can show them to the kids that, oh, let's say we have 3 fruits. We have pineapple, banana, and orange. Then we will show the 3 fruits to the kids. Then we tell them, oh, this fruit is pineapple, this one is orange, and this one is banana. We showed the fruits to the kids multiple times. Then at another time, we show the same fruits to the kids, but not telling them what the actual fruit is, but we expect them to know. If you know this, then in fact, you know how machine also learns. So using the kids learning as an analogy, we can take the original fruits that we show to the kids as, let's say, the features. So in machine learning, we call it the features. Then the actual fruit, so whether it's pineapple, mango, or any other fruit, that is a label. So you can think of them as the characteristics as the features, and the actual fruit or the name of the fruit as the label. Yeah, so that is exactly machine learning. So in machine learning, we are trying to learn some mapping of the data from input to an output. We are trying to learn some mapping from that. And if we remember from our basic school for math, we will see, let's say 4x is equal to 12, then they will tell us to find x. This x that we are finding, that is what machine is trying to learn. That is what machine learning, exactly machine learning in this case, is 3, because 3 multiplied by 4 will give you 12. But yeah, so that is machine learning. Machine learning, we have different types of machine learning. We have the supervised machine learning, where we have the actual labels. So when I use the kids learning as an example, that is a supervised learning. Supervised learning because we have the label, or we have the name of the fruit, and we tell the kid, this fruit is, let's say, mango. So we have the actual label. And in supervised learning, we have different types. We have regression and we have classification. So regression, we are trying to predict a continuous value. We are trying to predict a continuous number. So let's say in healthcare, we are trying to predict, let's say, how much a person is supposed to pay for a health cost or something. Anything that is continuous, that is regression. Then we have classification. Classification is when we are trying to predict a discrete value. So let's say a category. So given a patient's characteristics or features, we are trying to check whether the person has malaria or not, or whether the person has, let's say, diabetes or not. That is classification. Then we have the other type of machine learning, we call it unsupervised learning. Unsupervised learning in the sense that for that one, we don't have anything to supervise what the machine is learning. So we don't have anything to supervise. That's why we call it unsupervised learning. It means that we don't have the actual label, but then we are trying to see if there are some structure in the data that we have, and I will show you an example shortly. Then we also have reinforcement learning. For reinforcement learning, mostly I don't talk about it most often because it's mostly used in games. So let's say a machine, we can model something that, let's say, it learns from a data. Then we have three things in reinforcement learning. We have the reward, we have environment, and we have the action. So the agent will take an action. If it gets positive reward, it continues to do that, and if it gets negative reward, it take another action. But where it's taking that action, that is what we call environment. And if you have been following this news, or you have been following this type of machine learning, then you might have heard AlphaGo. AlphaGo is a research by Google that beats the best chess player in the world. And right now we see a lot of we are now seeing a lot of reinforcement learning in NLP and in LLMs also. So if you take ChatGPT, for instance, you go there, you type something, then we have a thumbs up there and a thumbs down there. The thumbs up, if you give a thumbs up, it means that you are telling the model that you are happy with the results and that the model should continue to give similar reward. And after a model is trained, so initially when we are building LLMs, they start training the next word prediction. Then after they get that part done, we refine, we make sure that the LLM's responses aligns with human values. So that's why we have reinforcement through human feedback. So essentially what we are doing is the LLM will give us the response. So let's say 2 responses, then a human being will choose which one they like or which one they think is the best response. And that is the reinforcement through human feedback. So even if you have been using ChatGPT for a long time or for some time, you see that sometimes it will give you 2 responses, then they will tell you to choose one. That is reinforcement learning through human feedback. Okay, so that is reinforcement learning. In unsupervised learning, we have clustering. If you know machine learning, then I'm sure you might have heard clustering. We have the k-means clustering, hierarchical clustering, and other clustering. So that is machine learning. Then I'll touch a bit on deep learning. Deep learning is a subset of machine learning, but here we are using neural networks. And someone may ask, what is neural networks? Neural network is another type of machine. It's an architecture inspired by how the brain works. So it was modeled to mimic how the brain works. So yeah, that is neural networks. We can stack layers. Then we see that from our brain, whenever we receive something, it goes through a lot of layers processing before we give out what we want to see. That is exactly how deep learning or neural network works. We have a bunch of layers that we can stack them together and process to make a very good to get very good results. We use deep learning for situations where we want to learn higher representation from data. So with the advent of deep learning, now people call machine learning as shallow models because deep learning is able to learn higher representations from data. That's why mostly we use deep learning. But yeah, machine learning is still king when it comes to tabular data or structured data, data that is in table. Machine learning still shines. And if you have data that is unstructured, like images, text, videos, audio, then deep learning is your go-to. Then we have AI, or what we see right now. So AI is the mother of machine learning and deep learning. So essentially, it's a bigger form of machine learning and deep learning. But we are trying to make sure that it's able to solve more complex problems. So you can think of at AI as a combination of machine learning and deep learning, but we are trying to make it solve more complex problems. And AI, but the type of AI that we see right now is the generative AI, these LLMs and image models, but we will touch on them briefly. Okay, so oh, sorry. Okay, so the role of machine learning in health or mental health in general. So we have, first of all, we have early disease detection. So we have these LLMs that can detect early diseases in patients. So let's say you go to the hospital, we can take your data, then these LLMs can generate data to check whether you are high risk of a particular disease. And I have a lot of projects on my Kaggle that I'll link to the chat, maybe if you want to check my Kaggle projects. If, let's say, you come to the hospital, we can take your, let's say, your blood, then we check the data, we check all that, feed it to the model, and the model will tell that, oh, you have, because of this thing, because of this, you have a high risk of this disease or sickness. Then we have personalized treatment. Right now, we have all these LLMs that can personalize information, that can personalize treatment based on your characteristics or based on only your data. So it's not based on general data, but based on only your data. Tita mentioned that we are generating a lot of data from wearables and all that. This wearable data, we can feed it to a model, and the model will tell you the kind of treatment that personalized treatment for you. In fact, it's unfortunate that some of these things that we are building at Zomujo, they are not out there, they are not out yet. I would have shown some of these things. In fact, most of these things, we are building some of them at Zomujo, and you should be, maybe the next time we come again, we'll be able to show some of them for you to see what we are using this. So it's not something abstract, it's something that we are actually building. And yeah, then we have clinical decision support. So right now, even at Zomujo, we have built something that the doctor can use to support his or her decision as to recommendations on your treatment and all that. But because these things are still in development stage, it will be difficult for me to give more information on them. Then we have medical imaging analysis. This part is what we see a lot of people building, and this is where deep learning shines. So clinical images, we can use deep learning to understand these, we can use deep learning to understand these images and classify them. So even in for one of my deep learning projects on Kaggle, I built a model that can detect anomalies in ECG. So we have data on ECG. But yeah, I mentioned the different types of machine learning. I mentioned unsupervised learning. So what I was doing is, I have some data on heartbeats, but then there are no categories as to whether this one is anomalous, or it's a normal heartbeat. And I built a deep learning model that can detect anomalies in the data. So what I did was, I think, what I did was I used autoencoders. If you know deep learning, then I'm sure maybe you might have heard autoencoders. But let me go to the next slide to talk about autoencoded, because I think that's where it is. Okay, so this is the autoencoders. This is what I use for the ECG model. So what we are trying to do is I was talking about clinical images and how we use deep learning for clinical images. And this is the architecture that I use for that project. So basically, this is what I am trying to do. We have images, we have images, we have readings of heartbeats, but then the data is separated into two. So we have the normal heartbeat and we have the one that is anomaly. So we have the normal heartbeats and we have the one that is anomalous, or they are not normal. Then I use the normal heartbeat. I use the data on the normal heartbeat to build the model. So this is what I'm trying to do. I take the data, I compress it. So this is the latent space representation, or the bottleneck. This is where the compression goes. So we try to compress the data. So let's say if we have, let's say we have 200 by 200 data. It's a tabular data, but then it's an image, but we have, no, it's a tabular data, but then we have showed them as a pandas data frame. So we compress them to, let's say, 64, so let's say 64 columns. Then we try to reconstruct it back. So what we are trying to do is we take the data, we take the original data. This one, from this image, it's showing as input image. But yeah, that is autoencoders is mostly used in images. That's why you see input image. So we have the data, we try to compress the data into a lower dimensional space. Then we try to reconstruct the data back to the original space. We know that the data will learn, the machine or the model will learn the weights from the data, and we try to reconstruct the image back. So what we are trying to do is we are using the original data as the input, and at the same time using it as an output. So that is the idea behind autoencoders. We have the original data, we use it as an input, then we use the same data as an output. So we take the original data, we compress it to a lower dimensional space, then we want to reconstruct it back. By reconstructing it back, it will not be perfect, it will not be the same as the original data. So we will have a loss function to determine. So we have a loss function to determine whether we are reaching the the original data, or we are not. We do not want to use the input straight to the output, because in that way, the model will not learn anything and will end up overfitting the model. So in this case, we try to compress the data. So how does the compression goes? If you know machine learning, then I think you know PCA, or principal components analysis. Principal components analysis, we take a higher dimensional data, or data, then we compress it to a smaller or a lower dimensional space. Mostly we do that in order to be able to visualize the data. We know that a graph, the highest a graph can go is a 3D graph. So we have 2D and 3D graph, but we can't have 4D or 5D graph. So let's say we have a data that is higher dimensional, we try to compress it to a lower dimensional so that we can visualize it. But that is machine learning. In deep learning, the PCA in machine learning assumes that there are some linear relationship between the input, but in deep learning we do not assume that linearity. That's why we use deep learning. We use a whole lot of activation functions. ReLU does not assume linearity. It's all assumed that the data is not linear. So that's why we use deep learning for that. Though you can use machine learning for autoencoders, but yeah, we use deep learning for that. And I will show you some results from the project that I did on Kaggle. So this is the results. If you know machine learning again, then I think you have used confusion metrics before. Confusion metrics is, yeah, in fact, confusing, but it's okay. So if you look at it, this is the summary of the results from the project that I did on Kaggle. So I have the anomalies data. So we have the model was able to, I don't know if you can see this. Can I show it? Okay. Okay, so I think this is okay. So you can see that we have the actual labels and we have the predicted labels. For the actual labels, we have anomaly and we have normal. The anomaly, the model was able to predict 72% of the anomaly data correct, 72.38%, and which represents 7,604. It's quite okay. But oh, sorry. Oh. Okay, then for the normal, the model was able to predict 93.4% of the normal. So if you look at the bottom, the x-axis, you see that the model was able to predict 93.4%, which represents 3,778. And the model incorrectly classified some of 6.6% as anomaly, though it was not anomaly. It was normal, sorry. Then for the anomalies, the model predicted 27.62% as normal, though they were anomaly. So that is also not correct. So if you take the first diagonal, this diagonal, that is the correct predictions of the model. Then if you take this diagonal, the right one, then that is the incorrect prediction. You see that for the normal, for the anomaly, the model was struggling to identify the normal because we trained the model to correctly classify normal heartbeats. So we use the model to predict normal heartbeat. That was the data that we trained on. We didn't train the model on this data. So that is essentially what autoencoders does. So we take the normal data, we train it on them, then we use it to predict the data that we didn't use it to train. Where it is not normal, it will have the model will give it will predict something, but it will result in a higher loss. But where the the model was able to get, because the data that we used to train the model, because the model was able to, the model saw the data, it can learn it, and it's already have that information in its weight. That's why it was able to get 93% correct. But this data, we did not train it on them. But essentially, because we have trained it on this, it should perform worse on this. It should not be perfect classifying the anomaly data. That's why we also have this. But if you look at this graph or the confusion matrix, you also notice something. The thing that you'll notice is that the normal data, the data that we trained the model on, was not big, like it was a small data, less than I think, let's say 4,000 data points, but the anomaly data, it's more than, let's say 1,000 data points. If you add this and this, I think it should be getting to 1,000 or 900 and something. So that is something that is the problem. And if you look at, oh, sorry, if you look at the the ROC curve, if you check the ROC curve, you can also see the true positive rate and the false positive rate. Yeah, but we will need to check what we are trying to do, whether we want the model to correctly classify or anomaly heartbeats, then we can set a threshold for that. But because of our time, let's move to the next one. Okay, so this one, I'll touch on this one briefly. It's not something that I did. It's
let's not go this one. Let's do this one.
Okay. So let's, maybe we'll send you the slide so you can go through this one. This one, in fact, is a research by some people, but it's essentially similar to the one that I talked about previously. So maybe you can go through them. Then we also have this research by Google. This research by Google was essentially a QA, or a question answering medical chatbot that was able to answer medical questions. So if you look at this graph, you see that the model was this graph that you see is essentially, okay, this graph that you see is essentially to answer US medical licensing exams questions. So they use US medical licensing exams. If you look at here, you see it there. And the model was able to get 86.5% correct. In fact, if you read the research paper, the average, or the pass mark, the average pass mark for these exams is usually 60%. But this research by Google, this model by Google, was able to get 86.5% correct, which is very nice. And if you check this part of the graph, that is here, this part of the graph, we are trying to, okay. So this part of the graph, we have where the chatbot gave an answer. So the chatbot gave answers. And we also have physicians or clinicians who also gave their answers. Then we ask the other physicians to select which of the answers that they want. So, or they think it's the best response. So if you look at the high quality answers, the answers for the yellow one is for the MedPAM from Google, and the blue one, the light blue one, is from the physicians. But yeah, so from the answers from the physicians, and you can see that the answers from Google, they were choosing that one a lot compared to the answers from the physicians, and that tells you why these LLMs are very powerful and these models are very powerful, and we need to build around them. Then we also have another aspect, potential answer risk, whether there are risk or there is some risk in the answer. The only part where we have the model from Google being risky is more accurate and relevant information. So this one, it was a bit risky. But apart from that, all the other aspects, the model shines. So yeah, I think you can see that from there. So that's why for this part, I would say if you are building around LLMs, building around AI, building around deep learning, then you need to check your evaluations. Tita mentioned that always you need to check whether you can do it manually. If you can't do it manually, then you can use AI to help you. Then we have other use cases of AI. We have AI that can analyze patient data and give responses. So yeah, so we have this. So even in Zomujo here, we have a platform, we have a software that can do that. So the patients that we have, if you're a patient, we take your data, we can feed it to the model, and the model can give you treatment based on your data. Then we have automated scheduling. If someone wants to book an appointment with someone, the AI can do that on our behalf and all that. Then we have remote monitoring and support. Because of these wearables that we have and all that, mostly if a patient do not need to come to a hospital, he can send us data on his wearable device, and yeah, we can analyze the data and provide him with information then provide emotional support. We know that in mental health, emotional support is it's something that we need to build around. We need to build something that can handle that. That's why in Zomujo, all the platforms that we are building or the projects that we are building, we incorporate some form of emotional support in them. We have models, we have LLM powered models and other projects. But for all the LLM powered models, we have emotional support for them. But yeah, so I think that is all I can talk for the machine learning, deep learning, and AI part. I don't know if anyone has a question. In fact, I like questions. If you have any question, you can ask me. Maybe you are building something and you want ideas as to how to go by it. You can ask me any question and I'll be glad to answer you. Yeah, hello. Yeah. Okay, yeah, Joel. So that is all I
Yes.
can say for. So if you
I
have any questions, you can go ahead and ask me any question. I like questions. So if anyone has question, maybe you are building something LLM powered. In fact, LLM powered is something that I do almost every day. So building around LLM powered app or anything, machine learning, deep learning, I'll be glad to answer that.
Okay, at the moment we don't have raised hands, but we have allowed all of you. You can unmute anyone with a comment. You can speak, or if you have a question or maybe a concern, maybe you're struggling as you set up your project in terms of how you're going actually to do it.
All right. So thank you so much, Joel. Thank you, Zach. Again, Zach took it to some parts of healthcare so that, I mean, anyone building can just look at it in terms of the full biopsychosocial approach. It's mental health, but it doesn't necessarily, whatever you're building shouldn't necessarily be, it doesn't have to provide a service necessarily. It could be the scheduling, the appointment. It could be handling the back-end office for therapists, for list therapists, for community health workers. It could you could be handling the back end of that to be able to speed service delivery, to be able to facilitate service delivery. You don't necessarily have to be the platform offering the service delivery. Again, so I mean, just to think about it holistically, there are different points to build around.
Okay, yeah, thank you, Tita. Yeah, that's why I mentioned earlier that though we are talking about mental health, but my presentation will take healthcare in general because, yeah, I think not all of us here are, some of us are also building around not only mental health, but around other aspects. Yeah, so if anyone has any question, still waiting for that.
Okay, no questions. That's a good thing.
Okay, thank you very much. If we don't have any other question, I don't see anyone using the chat for question also. Then we can, you can always feel free also to reach us if you have questions, maybe later on after this, and we can always share with our facilitator the questions or your concern.
Yes, sir. I have a question.
Okay, go ahead.
Will this presentation be shared with participants?
Yes, we will share with you on
Okay.
our platforms.
Awesome, thank you.
Great. Okay. Thank you very much. And maybe let me check if my colleague is here. Maybe.
Can I hear from Sylvia? Sylvia, hi. I've been having
Hi.
I've never got to how are you doing, Sylvia? How is work at APHRC?
I'm fine, Dr. Teacher. Thank
Good,
you.
good,
So,
good. And
yeah, so thank you so much for the presentation. I think it's really enlightening in terms of the practical aspects of developing technology aspects or tools for healthcare. And I think what you present covers all healthcare, although we are definitely more interested in mental health, but it does cover the spectrum of healthcare and what it entails, how we can build from the context in which we exist, and the challenges that we face across the continent. How do we reach the most vulnerable communities or individuals that could be left out by the technology itself? So while you say the technology is good and it helps us address those issues, so the tools don't work by themselves. There's the human aspect, the part that we need to focus on as well. So I really listened very keenly to what you said and what the tech side of things involves and how it can help our participants to put up very good proposals. So we haven't got to speak, but yeah, I think it's a very good thing. I've engaged with, I've seen some products from Cargo, so I am a bit, I have some familiarity with them. But yes, it opens up like new aspects for our participants to think through as they come up with their solutions or try to scale their solutions as well. So really grateful that you could talk about it. I mean, and have many questions perhaps for you. And one thing that might be of interest to people here is how, and this is a question for you, you talked about your journey from medical school and forming that group of maybe 100 people. What did it take to get to work with the tech side of things, to partner or to collaborate with the technology part, the Cargo group? What did it take and how did you navigate that process? So that's a question that I would comment, or if you want to comment on that, or if your colleague like to comment on that, that will be great.
okay. Thank you, Sylvia. The data prize, mental health data prize, this is a very good initiative, and we're happy to give this training on it. So, for that was the 120 was in the initial group. So far, we've trained over 1,000. Last time was about 1,250 to 1,300. I'll have to look at the exact number. Yes, and it was just, and that's just been in the space of, the training has been in the space of say 2 to 3 years. And how did we go about that? It was finding, again, it's like the snowball effect. I am going through something. I know a friend who is also going through it. He also knows someone who is also going through it. We're able to provide that support. We're able to go around, I mean, campus, Charlie, boys thing. We started with the boys group. Charlie, we did, be your brother's keeper. We did for you. And then people started subscribing to it, sorry. And soon, by the time we realized, oh, okay, people are interested in it. People just want to talk. People just want to vent out without being judged. People just want to also see others who are going through it, who will be there for them. Right? University, you could look at things like heartbreak, anxiety, people failing courses. Sometimes medical school professors fail. Students failing, somebody not understanding things. All these problems, family, home, and then you could find somebody who could relate to it. So it was just word of mouth, organic growth, and we've just restricted it that way. But the scaling, it's what I didn't talk about is now scaling. We're looking at partnering with a private organization, Ziptic, that is also trying to do some work. That's doing some work in the healthcare space, and then because the more it means for the nonprofit part, that was where we also got wrong, and I'll be very vulnerable with you on that. We got it wrong in that we are not for profit, and revenue is a good thing. Building the tech systems, when it's used by a large number of people, you have to pay for hosting, cloud servers, LLM. Like I said, it's not cheap when people use. And if you are not getting money if you are not charging people for that, then you might as well have to find a way. And then we can't always rely on foreign aid. We have to build products that are sustainable. We have to look at, if it's an NGO, there's the Mulago Foundation. The Mulago Foundation, there's something I've realized about them, that they always say that bingo, we have to feed into it's either we have big doers and then big payers. And if you are doing, you might as well feed into the big doer narrative. It's can your thing be taken up by the government, or is there a bigger, if it's for a not-for-profit, I'm taking a not-for-profit perspective. Is it a not-for-profit? Is it a big funding organization that wants you to see it go on for X number of years, or that? But if you're also going the private way, then it makes sense to also charge people for some premium access, some premium features. So the person who talked about the codes for CEOs, maybe not just CEOs, but if I was the one building that, I'll think about it not just for CEOs, for organizations. Say there's M-Pesa in Kenya, there's MTN. Do their employees go through this? Is there any data to show that their employees are usually burnt out? And what offering with this service you're going to give them is going to decrease, it's going to increase productivity by roughly X%, and by increasing productivity by X%, they are going to retain employees more. It's going to reduce absenteeism. You build a whole case around it, and then you're able to add pricing models. Maybe it starts with text-based motivational quotes. It adds maybe some screening assessments for satisfaction with life skill, the depression, anxieties, then it gets on from there. It gets on from there. Be able to check, and then maybe you have a bespoke offering where in that sense you have so we can still be able to go beyond that. I didn't touch on the sustainability point, but I think that is very important. If you are building, you should be looking at sustainability and how you can drive what you're doing and make more impact. Thank you.
Thanks, Didi. I think there are a few questions. There's maybe one question. on the chart. So how long would it take to build an AI, machine learning for personalized treatment? Something there.
Okay, let me expand and then, okay, sorry. Let me see the questions so that, all right, okay. Good, thank you. Okay, I should zoom out the slides for easy visibility. Oh, sorry. How long will it take to build an ML for personalized treatment? Sharon, that's a good one. Zach, you want to give it a try?
Okay, yeah. I think this one, it will depend on whether you have the data already, and it also depend on the kind of personnel that you have to build this. If you have the data already and you also have the right kind of personnel, then I think it shouldn't take a very long time. But if you don't have the data, then first of all, you need to gather some data. It's either you gather them manually, or you can also use a bigger model to generate any synthetic data. But yeah, it depends on the kind of model that you want to build. So I don't know if you may want to give clarification on the kind of machine learning you want to build. So Sharon, yeah, please, you can go ahead and give.
Yes, no, I was asking in terms of, according to your slide, I was wondering if I wanted to build model, maybe to assist clinicians in finding personalized treatment for mental health conditions, how long that would take me, the time frame I would need to prepare for that. Just I was wondering.
I think you are breaking off. I can't really hear you. Hello, Sharon.
Okay, Joel, can you help out? Can we try to get Sharon's question?
I think I also didn't catch that well,
Yeah.
but I think she's talking about the period.
Okay, so
Yeah, I know the period, and yeah, I was saying that it will depend on the kind of model, the kind of machine learning model she wants to build. That will help me know the kind of.
So, okay, and let me just also add this. You know, we should also be looking at the MVP. The minimum viable product is, for anyone building in the tech space, what is the core feature that I need to put out there? And if it should function, what is the earliest time that it should? Again, to build an LM for a personalized treatment is very broad. Is it, say, you're taking let's say schizophrenia, and you want the machine learning model to give a personalized treatment? In this case, it's a bit of a stretch, right? Because it means that it isn't going to give you, in this case, machine learning for personalized treatment. If is it in terms of clinical decision support, like CDS, in that case, have you gathered enough doctors, reviews, doctors notes, but these LLMs, when fine-tuned with local data and treatment guidelines with RAG, the random
Retrieval augmented generation.
Good. With the RAG system can help out with that. Or maybe recommendations. It depends exactly on what. But if you want to actually build anything, I would say have your MVP. What's your fair idea of what the MVP is? Get a UI designer or a full stack developer or a product manager. Sit down. This is the back end. That's going to require and then the front end. 6 to 9 months. Can I get it ready in 6 to 9 months or less? And also, you want to test user feedback. usually for tech builders, we are guilty of trying to condense as many features. We want to build out so much features before we roll out. You have to test, you are building for the users, for the public. You have to test their feedback and then take on from there. So I think it's, and not try to do so much at the first sweep. Otherwise, you could even run out of short funding, runway, things like that. So you take the earliest, the core functionality, and then you get a team of 2 to 3 people. I mean, I'm guessing software devs, communicate the idea, see, can we have this thing in real world, actively testing the waters in 6 months or less, and then we do that. So that would be my general approach to building. And then you begin to build on top. So it gets better. You see people using, okay, 100 is for, can we take it to 1,000?
Yet. If some, let's say an individual has, or group of individuals from the medical side, from the mental health or medical side, and they would like to partner with the technology, find a partner. What's your advice in finding the right technology or innovation or data science partner to work with? What's your experience around that?
That's a good one, Sylvia. You see, again, Sylvia, thank you so much for bringing this up. That's why I'm not so fan of slides, because these things are very relevant, but I mean, how to find the right partners to work on the project with. I think that we are building a tech application or a tech, application. So it's good you have tech people, especially for the non-technical founders. This could be asking within network. If you look at the Silicon Valley framework and why schools like Stanford, and there's always funding for them, is you have a computer science student, maybe 2 computer science students, or a computer science student, and let's say a pre-med or a medical student. You ask around. For my kids, asking around, oh, can you recommend somebody who is very good, maybe a young guy who is very good at building, let's say, software, building applications? You ask around, somebody will refer you till you get someone who you think that, has the skill set. It could be 2 people, it could be 3 people, depending on the time you want to achieve the MVP. Depending on the time you want to achieve the MVP, it could be 2 to 3 people. And then it's also about the plan, the agreement. For example, in the typical tech startup, a founder, co-founder, so the CEO, the co-founder, the technical one, the CTO, they can go to a 50-50 split. So if it's just 3 people, you can look at it as maybe, or 4 people, 25%. So you draw that agreement. But for me, it's about asking around, going to the universities, going to companies, tech companies or companies, having friends there, asking about who can get this done. It's really about asking around. I mean, somebody within your network will know someone who will know someone. And then once you sit together, you may not have the money. In my case, when I was building, I didn't really have the money to onboard the people. But once you don't have, that's why equity comes in. You know what? I'm building this great product. I think this could be the next big thing for Uganda, for Kenya, for Ghana, in terms of mental health space. I want you to come on board. We are 3, you'll be the 4th person. We'll all take it, maybe 25% equity. This is what we want to do. These are the deliverables. What do you think? And maybe you put in a cliff, a founder cliff, a vesting cliff of 4 years, 5 years, right? Over 4 years period, maybe it will mature across 4 or 5 years period, right? So let's all get in on this and build. Typically, that is the approach I would go for. I don't know if it helps.
Yeah, thanks. That really helps.
Yeah.
Good. Yeah. Back to you, Joel.
Good. And I also think that, I mean, as a practical side of things, the person should be someone you're thinking of when you're building this. It's not a 1 year thing, it's not a 6 month thing. Is this person somebody I can quote unquote be in bed with for the next 5 years? So sometimes a good history of being together for long really helps. I mean, maybe we were in college together, we attended high school together. The first tech startup I built, it was somebody who we had grown up from the same neighborhood, being in the same same high school, same university, known each other, friends for many years. In that sense, I mean, now he works for a Silicon Valley he does these Silicon Valley companies remote work. That was the whole approach. We had known each other for long, good chemistry, build something enough. You can sell it and then move on with your life after the acquisition. It just plays out that way. So really that's the approach I would go for. Go for friendship, go with skill, go with Can I ask partner how
Networks? Through existing networks, or if I'm always looking out if I'm at a conference, if I'm at a meeting, looking out for new people who are doing things in different ways, doing different things all over. So I think I really bank on the networks and the people I know to have that the same effect, the snowball. If you know someone who does this, and then I reach out to those people. Yeah. And usually it works somehow. It
Yeah.
works well. Yeah. With the partnerships.
Yeah.
So I think it's a good thing.
Yeah. And then I mean, for a conference like this, I'm very grateful. I've looked through the names, I've taken notes of the names, I've even written, I've taken screenshots. Who knows? One day we may come to East Africa. We may need local partners. We may need somebody to spearhead things over there, somebody with enough experience, somebody who has built something there. It could be all through this. It could be meeting this, it could be somebody asking the question, it could be saying, Sylvia, please can you recommend somebody within your network who you think can get this done? That's the way it works.
Yeah, sure. So for the sake of our participants, because it's now top of the hour, but I don't think we've seen you virtually, like on the video. Maybe, yeah, if they find you or if they can see you, that would be good.
Okay, all right.
Yeah.
Let me position well.
Mm.
Hi. Sorry, I'm in the
Yeah,
hospital
so
environment, so I'll just put on my,
okay.
don't worry,
No.
I'll just put on my laptop camera and then we can take it on from there.
Okay, good.
Okay.
Yeah. I think it was great. Okay, good.
I don't know. Can you see me? Hi.
Yes, we can see you.
Oh.
Yeah, it's been, yeah. Yeah, I'll give the mic back to Joel, who will close. But thank you so much. If we don't have any more questions, perhaps, but it's been a pleasure to have you on the call, and I'm really glad that you got to talk about the role of lived experience. So having a person with lived experience working alongside the development of the tools and how we could reach those populations that are marginalized or left out or vulnerable in some ways, and then bringing the technology sides. So thank you so much.
Thank you. Thank you. It's a pleasure. And I would like an update on, the progress on things. I know that the data prize will be on later this year, and I'd want to see what you guys are all building. I'd like to hear great stories. I'd like to follow on to see. I hope that this will open up for good partnerships and then greater impact. And I'm always available to help. Always available to help.
Sure.
All right.
Sure. Thank you so much.
Thank you.
It was great. Back to you, Joel.
Okay. Thank you very much, and for the wonderful presentation. I think that was quite nice, the merge and between health and technology, and even for bringing out again the lived experience, which is actually also central to this project. So I know most of our participants have captured a lot. And maybe and have a great afternoon.
Thank you.
Bye-bye.
Thank you. Thank you. Bye-bye.
Bye-bye.
Thank you, everyone. I've seen the names: Antonia, Sian Edward, Sharon, Suleiman. Happy to connect with everybody here. Thank you so much. It's been a pleasure.
Great.
Great. Thank you.
Thank you.